The critical path analysis. The critical path analysis or critical path method is a scheduling technique used to determine the duration of a project by identifying all the dependencies and define the longest set of dependent activities. It is used to control the project schedule. A delay in any activity of the critical path will delay the project. The essential concept behind the critical path is that all activities in the schedule have some type of dependencies. Dependencies are where you can't start an activity until other activities are finished. These tasks need to be completed in sequence. The critical path, it is the longest sequence of activities from start to finish. By focusing on the tasks that make up the critical path, the project manager can maximize the chances of completing the project on time. If activity in the critical path is delayed, it will delay the entire project. When a project manager is faced with delays in the schedule, an analysis of the critical path will be the first area to identify solutions to solve the delay. The calculation for the critical path can be complex if the project is large. For those situations, project managers use a scheduling software that can make the analysis much easier, especially when there is the need to explore different scenarios. Most scheduling software, such as MS Project, can calculate automatically the critical path and identify the activities or tasks that are in the critical path. Let's look at a simple example. After the team has estimated the duration of each activity, the next step is to identify the dependencies among the activities. Some activities can only start after another activity ends. Here are the most common types of dependencies that can exist. Finish to start dependency, finish to finish dependency, and start to start dependency. The most common type is the finish to start dependency, in which it can even include a lag or time before the next activity starts. Once all dependencies are identified, the next step is to create a network diagram that connects all activities. Dependencies are also classified into two types, mandatory and discretionary. Mandatory are activities that must be performed in a sequence. For example, you need to complete the foundations before you start building the columns and the walls. Discretionary dependencies are flexible. For example, the purchase of furniture could happen at any time before the end of the project. In the network diagram, there can be many paths that connect activities from start to end. The dependencies create a series of paths that go from start to the end in a project. In the next step, the team will calculate the duration of each path by adding the time it takes for each activity. The path with the longest duration is called the critical path. In this example, the critical path, marked in red, has a duration of 100 days. It is called critical path because a delay in any activity in that path will cause a delay in the entire project. In this example, if activity 1.13 is delayed by a day, the entire project will be delayed by a day. But if activity 3.1.1 is delayed by a day, it will not affect the end of the project since the duration of that path is only 65 days. Another characteristic of the critical path is the part where there is no float or slack between activities. If we rearrange activities in the network diagram, it will look something like this. Note that in the critical path, the red line, there are no spaces left between the activities. Float or slack refers to the amount of time that is added between a predecessor task or its successor. In the diagram, all the other paths contains activities that have float or slack, meaning they have some time available for delays without affecting the end of the project. Understanding the critical path of the project allows the project manager to prioritize which tasks require a greater focus. Those tasks falling along the critical path directly impact the ability of the project manager to complete the project on time. Any delay in this task can set back the project completion date.